In this video we're going to look at how we can use graph sketching to help find the number of intersections of curves. So in this first example we're going to look at the two curves x negative 3 multiplied by x plus 2, which we should work out, or we should recognise as being a quadratic, and then the second one we have here, which is a cubic. I'm going to try and find how many intersections there are. So how many solutions are there to the simultaneous equations of this pair? So the way I'm going to do it is I'm going to sketch each function. So I'm going to go through that quite quickly because there are other videos in this series on how to actually sketch them. So the first one is going to cross the x-axis at 3 and negative 2. So that gives me 3, 0 and negative 2, 0. It's pairs of coordinates. And by substituting in x equals 0, I get the y coordinate intersect, which is 0 and negative 6. So I'm going to do a set of axes. I'm just going to wait for a moment before I actually put this on, because I'm going to check my second function to get an idea of the scale I need. So this has solutions at negative 1, 0, 2, 0 and 5, 0. And then if I substitute in x equals 0, I will get 0, 10. So I'm actually going to end up with 10 as the highest point I need to use, and that's for the cubic, and it also crosses at 5, 2 and negative 1, and x multiplied by x gives me x cubed, which gives me an indication that it's going to start off as an increasing function. So it's going to cross through 1, go through 10, come back down through 2, and then up through 5. And now I can have a look at sketching the parabola, the quadratic. So that crosses through at 3 and negative 2, and it crosses through at negative 6, and x multiplied by x gives me x squared, so it's going to start off, it's going to be this shaped parabola. So it crosses through at negative 2, negative 6 and up through 3. And I haven't quite drawn this enough, but because a cubic is going to increase at a faster rate than a quadratic, it is actually going to intersect up there. So how many intersections have I got? I've got 1, I've got 2, and I've got 3. So there are 3 positions in which, or 3 pairs of coordinates, which are going to satisfy both of these equations. So this second example, I'm going to do much the same. I'm going to start with the cubic here, because this one I can recognise as a reciprocal function. That's actually going to be very easy to sketch. So this is going to have solutions at 3, 0 from this bracket, and this is squared, so this is going to be where it touches the axis. And then at 4, 0, and that's not squared, so that's going to pass through the axis. And then if x is 0, I will get, so negative 3 squared is 9, multiplied by negative 4 is going to give me negative 36. So I'm going to draw my set of axes. And I've got an intercept right down at negative 36, and then at 3, 0, and 4, 0. And then I've got x squared multiplied by x is x cubed, so that tells me it's going to initially be an increasing function, and it's just going to touch at x is 3. So it's going to increase x equals 3. It's going to touch, and then it's going to come down, and then it's going to pass back up through at 4. And then I'm going to sketch the reciprocal part, so that's asymptotic, so it's going to be that shape, and there's going to be another solution down here, and it's going to be this shape, and I can see there is one solution down here and one solution up here, so there are two intersections of these two curves.